Okay. All right. So I see people from India, from Anambra State. Welcome, everyone. Welcome. Okay. Oh, from which state? Abuja again. Please, I want us to mute our microphones. Please mute your microphone. You know, just observe house rules. Oh, Florence from Ghana. Lovely. You know, I'm so happy to see people out of Nigeria here joining us. Oh, I see Paul all the way from Sokoto. Wow, lovely. Thank you. Another person from India. Rita, do you see this? Someone from India. I see.
Yes.
Okay. Oh,
That's
nice.
very good.
That's nice. I see Hawa from Kano State, Femi from Lagos, Omolara from Lagos. Who? Let us drop. Let me know. You just coming in. Where are you logging in from? Which part of the country? Which part of the world you're logging in from? Let us know your name, the subject you teach. Welcome. Please just feel free. Let's you know, lighten up the mood. We shouldn't be that tensed. We're not going. It's not an exam yet. So let's all be relaxed and calm. Okay, it's atmosphere for learning to, you know, to take STEM education to our learners forward in an easy and interactive and wonderful, engaging way. I see Deborah from Ogun State. I see Olawale from Lagos. Okay, great. Welcome everyone. Oh, Martina from Kano. Nice. How is the north going? I hope you're staying safe there. Everyone, my brothers and sisters in the north, I hope you're all staying safe. Okay. I see Anita from Abuja. Great. Welcome, everyone. Welcome. I need to actually take a screenshot of this, you know, to show people that we are here. We are here and we are ready to take STEM education to another level. Okay? So thank you so much, everyone, for joining this early. Thank you so much. So quickly, because of our time, I would quickly do the honors. If you're joining, please kindly mute your microphones as you join us. Mute your microphones then, okay? All right, then you can introduce yourself in the chat box. Mute your microphones and introduce yourselves in the chat box. Okay, let me share my screen. Rita, can you see my screen?
Yes.
Okay. Let me just quickly type on because a lot of people are calling me. Let me just drop a message that I can't really pick anyone's call right now. Kindly join through the link. Rita, can you help me reshare the link on the group itself, on the WhatsApp group? Yeah, I've shared it just earlier on. Please help me resend the link. Okay, thank you so much.
All right.
Okay. So welcome everyone once again to our session. 1 minute, sorry. Ooh. So welcome to the introduction to STEM and PhET interactive simulation. So here we're going to be introducing you to what PhET is all about. You have been seeing PhET. So what is PhET? I'm even wearing a t-shirt. PhET. What is PhET?
Blessing, you need to enable us to share because I think I can't. Can I share
your screen?
No, I mean admin to share in that.
Yes, you're an admin. You're an admin there. You're an admin.
Okay.
Yeah, you're an admin there. Okay, so what is PhET about? That is what we're about to find out now. And how is it engaging? Is it a tool that you can use? Has other people been using it? Has other teachers been using it? You know, you're about to find that out today. All right. So just quickly, a brief introduction of the team today. All right. So Dr. Rebecca Vieira is going to join us soon. Okay, and she's a director of the Global Initiatives of PhET in Colorado Boulder, USA. Also, we have Professor Olayinka, is the Dean, Faculty of Science at Edo State University. Also with me, I have Rita Oladiran, who is a PhET Fellow, okay, in Nigeria, and also the BISTEM 24 EdTech founder. And you have me here, your host, Blessing Sheun Chukwuka, a PhET Fellow in Nigeria, also the founder of DTW Tutorials. So just quickly taking introductions here. So for, okay, good. All right. So quickly, just a brief profile of, sorry. So just a brief profile of my prof here. I'm so sorry about this error here. Okay. My Professor Olayinka is a distinguished academic and computational and applied physicist. Okay. And he has been recognized via his several contributions in education, research, community service. All right. He has a PhD in physics from the University of Benin, and he specializes in engineering management, condensed matter physics, and computer science. All right. He also has an initiative, He has a foundation, all right, which is Center for Computational Science, which he leads to impact the world of science, especially physics. All right. So he has is also a PhET fellow, and is also an ambassador with the Lab Exchange program at the Harvard University. So, you know, this is just a brief citation. In fact, the citation is over 3-4 pages. I had to just, you know, compress it.
Summarize.
I just had to summarize because I can't. You can imagine a prof, how many things you know, is citation. In fact, if you need a citation, I will forward it to you personally. Okay, and you will read through all his achievements. Okay, and here I'm quickly going, Prof, I'm so sorry about this, the name error there. Please, I apologize. So I'm quickly going to Rita. Rita is a STEM education specialist, and she focuses on digital teaching, how to build digital curriculums, and is also a learning expert. She's also an educational development professional with over 8 years experience in enhancing the way students learn and also helping them achieve higher academical performance and grades achievements. Okay, she's also the founder of BISTEM 24, a non-profit, that's an NGO. She's the founder of the NGO, and she has been running several programs, even in the north, in the there's one she just ran last year in Kaduna, I think last year or last 2 years
in India.
Oh, okay, in India. And you know, she's always learning, always trying to, you know, improve learning outcomes through applying, you know, various digital pedagogies. Okay, because definitely we are in the digital age, and the earlier we embrace it, the better for us as a country. I also have with me Joy Chidima, Miss Joy Chidima. She's a certified PhET teacher. She was just once like you. She enrolled in the second workshop. Please, Mohammed, please mute your microphone. Okay, she enrolled the second workshop, and she's certified by the University of Colorado Boulder, and today with us facilitating. Rita, please, can you help me mute people in the background, please? So, and today she's with us facilitating. She has over 9 years experience as a chemistry teacher. You can see she has a BSc Education Chemistry, Checkpoint, you know, IGCSE, A-level chemistry teacher. She's also an assistant examiner, and she has an online platform, online teaching chemistry online. So wonderful, 9 years experience. That is Miss Joy we have here.
Unmute yourself, Blessing.
All right. Okay. So thank you. Thank you so much. So these are, someone is writing on the screen. Please, can you don't annotate on the screen, please?
Yeah, please do
Okay.
not annotate on the screens.
I think, can you help me check the setting and maybe put it off? So, my professor and Dr. Rebecca and Mrs. Rita and Miss Joy are going to join me today in bringing you into the wonderful world of PhET simulations, and you won't regret it today. Okay, so quickly, I'm just going to give a brief introduction about the host. All right, so the host of this particular workshop is DTW Foundation. All right, and let me just a brief how the DTW starts and how did the foundation come about. So first of all, we started as a YouTube channel, just creating content for definitely WAEC, the West African students, exam body, WAEC and JAM. And that's why I started creating free content. Wow, a lot of people are just calling. I'm so sorry. So creating free content for maths and physics and some other science subjects. So I started from that, helping students out, making sure that at least they can follow through. One of my major desire was to stop this exam malpractice, because I see it as eroding our system. It's not just education, even our country itself. So I sat back home and said, let me help these kids with free videos, teach them, okay, solve questions for them from their exam past questions, teach them, explain. After classes, maybe definitely the ratio of teacher to students in most schools are in fact, a teacher can't cope. Are you with me? A teacher can't cope. So it's not all students that will be carried along. So, okay, let me now do some digital contents that will help. And that's where that desire came from, to stop exam malpractice. And I started doing this. But along the line, I see that there's also a need for teachers themselves to be carried along. Okay, because if you help, they said if you train a teacher, you have already touched several thousands of students that would pass through them. So that's where the foundation came about, a ways to reach teachers, to train them, and also to counsel youth, vocational counseling, and other guidance. So that's how DTW Foundation started, and PhET came into the play, and we took up PhET. PhET is also an NGO. You're going to know a bit more about PhET in a few minutes. Okay, so an NGO supporting also an NGO and bringing this free to Nigerian educators. Okay, so that's how DTW Foundation started. So we started from YouTube, where right now we have over 63,000 subscribers. We have reached over 3 million Nigerian youths, providing good content that will help them. There are several success testimonies. You can go on the YouTube channel, just go through comments, you see several testimonials there, okay, as proof that this has really touched and impacted students. All right, and we also have several educational apps which you can check on our Play Store. We have the JAM app, we have the WAEC app, we have the NC app for the primary. We also have the Junior WAEC app you can check on the Play Store to see, download freely and go through it. And you see how wonderful you can use this to prep your students for their examination. So we are here to encourage them. Everyone, when I try this particular training, they're like, what of us literature students and teachers? What of us English teachers? What of other subjects? You only STEM. And I'm like, it is STEM, I know. So let me focus on my people. My people, do you agree? Let me see a thumbs up. Do you agree? Let me see your thumbs up. Let me focus on where I know. Because everybody will be saying, where is this subject? Let me focus on where I know. So that's why I'm here for you, my STEM people. Everly here, serving you by God's grace. So that's where our teacher training and development started. So far, through the foundation, over 1,500 teachers have been trained, okay, and certified through the PhET workshop. Thank you, my people, for the thumbs up. Encourage me. Thank you. All right. So now, please, the workshop object, okay? Yes, allow. Yes. So this is our workshop objectives right now, our expectations. Please, I want us to listen carefully. This is very key and important, so we don't miss it. Okay? Now, as I speak to you, I don't know if Rebecca, are you here?
Yes, I am here.
Oh, thank you, Rebecca. Rebecca, have you sent the invite yet?
They are actually going out right now, and just a reminder, Blessing, they'll be getting four emails. So everybody should be on here. Sorry.
Okay.
Everybody on here should be receiving in the next few minutes 4 emails. One that is Introduction to PhET, the next one, which is Whole Class Inquiry with PhET, and then Activity Design, and then Implementation. So the Introduction to PhET has been split into 2 courses just to make it a little bit easier. So you should have 2 invitations so far. You'll be getting 4 in the next few minutes. And just because the introduction was sent first, it will look like it'll look like the email lowest below. So everybody would start with introduction. All right, okay. I'm going to finish that up right now, Blessing.
Okay. While Rebecca is working on it, let me quickly explain. All right, let me quickly explain it quickly. Okay, so now you would receive 4 emails. Okay, what she just notified me now is that the introduction has been split into 2, no longer 1. But you're going to see something like this. Rebecca, I hope it's still going to carry Nigerian STEM Teach. Is it?
Yes, it all looks exactly the same otherwise. And I think it's actually been like this for a while, Blessing. So it's fine. People will be fine.
Okay, good. Okay, so please, you're going to receive by now, as she said, each and every one of us, before we finish, I think the mails take, because it's a bit a lot, so it's going to take like 2 hours to drop in your mailbox. But what you'll be seeing is Nigerian STEM Teach. Join Nigerian STEM Teachers. Are you with me? That's what you're going to be seeing. Please, can you stop writing on the screen, please? So you're going to have 4 emails. Please, you will start with introduction. All right. You have to join from the email. That's how you join the course. So as I've been sharing all the works, because you're going to be having assignments, so everything will be on Coursera. Now, this is, you know that Coursera is a paid platform. You pay $69 per month on Coursera. $69 right now in Nigeria is like 90,000 naira. But PhET has made it free for every teacher in Africa. Are you following me? So for you not to be led to go to pay, you have to join the course from these invites, these emails that you receive, please. Because that's a major problem. Everyone comes back and say, oh, it's telling me to pay. It's because you didn't join. So when you receive the 4 emails, I advise you immediately join the 4 of them. Immediately click into join, click into the introduction, click join. Go to the second one, click join. Go to the 3rd email, click join. Go to the 4th email, click join. Don't wait. Don't click them. Because what happens is when you click join, it takes you to Coursera. Then what then happens is Coursera has a way to now start recommending the continuation of the course. And when you go and click from Coursera, it not asks you to pay. So it's best you click join now in the 4 courses. So it's already on your dashboard. Are you with me? So when you're ready to now go to the 2nd, the 3rd, and 4th, I hope you're following me. There will be no issues. So please, immediately, please, I repeat again, let us join. Before we finish the course, you're going to receive those 4 emails, or even later at night. If the server slows, you will receive them tonight. She's already sending it now. So immediately, please click join. Please, very important. All right. So to avoid any, technical queries and, you asking me, trying to help you solve it. We're going back. We have to log you out. We have to create another account. It takes a lot of work. And it's going to be a lot of work for me. And I'm doing this for free. So please don't let the work be too much for me. Are you, please? I beg everyone on that. All right. So thank you. So today we're looking at introduction. Yes.
Now, I want to join now or after the trade.
After the class, after
Okay,
the webinar, just
right.
after.
Thank
Okay. I'm just saying this after the webinar, then you go in to start your assignments. Okay. So today we're looking at introduction to PhET Sim, learning what makes PhET Sim unique, embedding it, whole class inquiry, everything will be run through our wonderful facilitators. The next week, Wednesday, we're going to be looking at activity design, how to create your activity sheet. That's what we're going to be looking at with the particular sim that you have, chosen to use. Then the third week, it is 3 synchronous workshop together. The third week, we're looking at implementation. How do you carry this out now in your classroom with your students? That's what we're going to be looking at. Okay. So, all right. Please mute your microphone. So by the end of this session, you will understand STEM and its relevance, appreciate the importance of EdTech in the classroom. You'll be able to locate, interact with PhET Simulations EdTech app, implement a PhET simulation with your students, and help, how to find help and support for using PhET. That's what you're going to get today. Just to quickly go further. So, the question is, why STEM? Why STEM? That's the question. We've all seen, we can't overemphasize why STEM is important, why we should encourage more learners to go into the STEM field. We all saw what happened during COVID. I keep on repeating this. It was not the entertainers that helped out. It was not the footballers. It was not which other field again? It was not the painters that helped out. Are you with me? It was the STEM people that stood on the forefront of COVID to battle it. It was the scientists. Please let us mute our microphones. It was the scientists, it was the doctors, even the engineers building facilities to contain all those tents, the oxygen we needed. It was all science students, learners, science-based professionals. So we need STEM. And not only that, every country, every religion, every culture stands on STEM. Civilization stands on STEM. So we need, even food, making food, processing food, it stands on STEM, not the knowledge of STEM. So we can't overemphasize why we need STEM, why we need to make more learners be interested in STEM, not to make them run away. If we have a tool such as PhET Simulations, this will help them love STEM and want to engage and want to become STEM learners and STEM professionals. So we need it because even in Africa, we are behind most other regions. So if we step up this, create more people loving STEM and kids coming out being innovative, the better for our economy. There will definitely be economic growth, not going out to always import. We can start creating things ourselves in-house. That's why everyone knows that Africa needs to step up. And that's why the help from PhET Simulations from the University of Colorado Boulder has come forth to help us step up. And the one place that is the foundation of stepping up STEM in any country is from the classroom. Let us look at China. We say this thing jokingly, TikTok in China is different from TikTok in Nigeria. We say it jokingly, but it is true. Because they are focused on STEM. Each child knows coding, knows how to break a part, electronics. It's been enforced. So we know that one day we shall get there in Nigeria and in Africa. Okay, so the bottom line is STEM what fosters growth of economies. So we need it in our classroom. And we as STEM teachers are in the forefront of making this happen. That's why you are important as a STEM educator. So I will quickly just go through this. That why do we need to teach and learn with technology? We see a picture here and we see another here. Which is more engaging? Which is more interactive? Which do you feel kids of nowadays will interact better with? Peaceful, please stop annotating on the screen. Please, which, I want you to drop in the chat box, which do you think students will really engage with that will stick in their memory? Which do you think? Can I see in the chat box? Can I see people dropping? Which do you think? Which particular, this is the Rhodes method of learning, and this is learning with technology. Which, oh, I see.
Peter says the second frame.
Okay, good.
Everyone says the second one.
Everyone says the
Pretty
second
much
one.
everyone says the second one.
Okay, so we have to reduce this Rhodes learning and come and step up as educators. And I'm so happy they are here and adding value to yourself. No matter how little this value is adding to you, to your career, I tell you, it will help you earn more if you sell yourself well, just at the end of the day, having this particular certificate. Thank you, everyone, for your responses. I appreciate. Rebecca, I don't know if you can help me with the setting to stop people from writing on the screen. Can you help
possibly.
me?
Can you make me a co-host, please?
Okay. All right, 1 minute. Oh, Rita, I'm saying, where are you?
Look for Rebecca.
Okay. Yeah, I've made you.
Okay, all right, I'll try to work on it.
Okay, thank you so much, Rita. Please, Mujidat, please stop writing on the screen, please. Please, Mujidat. Okay? All right. So that's why we need to learn with technology and teach with technology. Thank you so much, everyone, for your responses. So quickly into what PhET simulations is all about. All right. So what is PhET? PhET is what? Physics education technology. PhET started with physics first. Why did it start with physics? I think that's the question. It started with physics because the founder of PhET, okay, he won a Nobel Prize award in physics. He's a professor of physics. He's at the University of Colorado Boulder. That's Carl Wieman. Okay, he won this in 2001, a Nobel Prize, and he used all that money to set up PhET as a foundation in 2002. Okay, so this is a wonderful thing he has done. He started from physics, and before you know what's happening, chemistry, you know, people from the profession of chemistry came and, oh, we love what you're doing, you know, help us out. We're going to give you funds because an NGO, all right? So they depend on funds. So, you know, and other subjects, you know, joined. So this is how PhET, you know, started. And now you have math simulation, you have physics simulations, you have chemistry simulations, you have biology simulations. All right, don't worry, very soon, Rebecca will take us through a tour of the PhET website. So now, what is PhET about simply? You know, it's an interactive simulation that makes STEM learning more engaging, more relevant, okay, more accessible to students. It's so gamified, it's personalized, and it immediately you're imputing something, you're seeing the reaction. It's just like in chemical reaction, you see acid, base, and salt, you see the way it's reacting. It has come to complement every of our work, even in our physical laboratories. That's what PhET simulation has come to do. So it's effective to use in understanding particular STEM concepts, all right, and practices, help students understanding. This is what PhET does. Okay, so, and you can say that PhET interactive simulation is more like what? Making what STEM, okay, is more like learning STEM, more like doing STEM. So it's making STEM more like you're doing it. All right, but right now it's more virtual, it's more digital, okay, not physical. So it's like modeling a physical situation, physical experiment, physical concept in a digital format. So sometimes, if you don't even have enough laboratory equipment, you can use a PhET simulation to conduct experiments, and you will see some simulations soon. All right, so Rebecca, up to you. Let me stop sharing.
All right, great. Yeah, and I'm so sorry. I was not able to get rid of the annotations. I think you have to do it on your end. But once you stop sharing and I share, it'll go away. So go ahead and stop sharing, please, Blessing.
All right, 1 minute. Okay. Yeah.
Great.
Okay.
Awesome.
Hello,
Thank
Rebecca.
you. I'm doing well. How are you? I hope everybody's doing well. It's good to see Blessing and Rita and all the others who might be here who I might know. I am dropping a link in the chat right now so that you can also go to the website that I'm going to show you. So let me share the screen. So I was a teacher in public schools and government schools here in the United States. And now I oversee a team of people who support educators all around the world. And I'm so grateful to Blessing for having given such a nice introduction to PhET. I would like to show you what it actually is. So the website, like Blessing said, is free. You just click on Explore Sims, and then these are what simulations are. There are lots of different things that we have simulations for, but our main categories are physics, chemistry, mathematics, earth and space science, and biology. So I'm going to show you just a few of my favorites. Let's see, Blessing, what do you think? Do you think we have more math or science teachers here today?
I think we have more science.
More science. So let me actually show you one of our newest simulations that just came out a few days ago. So a simulation is like a laboratory space. And so, you know, not all classrooms will have lots and lots of equipment, or maybe even any, you know, equipment for doing math and or for doing, you know, science experiments. But simulations can be really, really good, not just as a replacement, but actually sometimes can be even better. And there's a lot of stuff that even if you have things like light bulbs and circuits and magnets, if you're lucky enough to have those things, students still can't see things like magnetic fields and changes in magnetic fields. Sometimes, even though they can see a light bulb turn on, they can't actually see electrons flowing through a circuit. So there's lots of reasons why PhET simulations can be really powerful. We can also do things like changing variables. So we want to slow down a process, or perhaps we want to change things like to make the light bulb brighter or dimmer. We might play with how big an electrical circuit a loop is, or we might even add wire so we have multiple loops. And we might do things like change the strength of the magnet. Now, if you know anything about what we're showing you here, this is actually what's happening at the core of a generator. So it's really relevant to all students' lives. You might have a generator at home, or you might even think about an electrical power plant, where maybe you actually have a waterfall that's powering, you know, creating electricity, or you might be using coal or oil, something like that. But pretty much in every single case, you've got a magnet that's turning and that's causing electrons to move back and forth. So that's one example of a simulation. Let me show you just a few others from other sciences. Some of the simulations, let me show you another favorite. Let's say you wanted to teach your students about gas properties. And you can do things like add gas to a box and take a look at how adding that gas influences the pressure, or how it affects the temperature. Or I'm going to actually heat it up and we could see what happens to the pressure inside. You can see the pressure's going up. And what's really nice is I can actually pause this and I could have my students take a look at what the pressure is and what the temperature is. And I could, at a later time, heat up the box some more and pause it and collect more data. So simulations are really, really good for doing labs. And I want to show you just a few also for younger children too. So let me go into, this one is all about biology, and it can be used for young children, but it could also be used for much more advanced children. So here we have a bunny, and I would like there to be more bunnies. So I'm going to add another bunny, and time is going to pass by, and we're going to get more bunnies, hopefully. And we can teach students about the environment, but we can also introduce things like different kinds of genetic mutations. So perhaps I want to add in a genetic mutation so that we'll have maybe some bunnies that are born with a different color. And let's see what we get. Oh, We have a few bunnies that are different colors, but now we're going to bring in the wolves. Which bunnies do you think are going to survive when I bring the wolves in? Any ideas? You can type in the chat. Let me take a look. Which bunnies will survive? There's brown bunnies and white bunnies. Let's take a look. Before the bunnies take over the world, I'm going to bring in some bunnies. I'm sorry, bring in some wolves. Oh, the bunnies took over the world. That's not good. I'm going to have to start over. We'll try this one more time. And I'll also speed it up so it's a little bit faster. Give it just a moment here. And there's such an opportunity here. Oh, I see lots of people are voting. We've got people who are saying brown, most people are saying brown, some people are saying white. The white ones are definitely dominant, and you'll notice the white ones really, really stand out compared to the brown ones. Let's see if we can get some brown ones in a minute. We have one brown one, we have another brown one there. And now the wolves are gonna come, and they don't tend to eat the brown ones as much. And so after a little bit of time, we'll start to see the population shift as other colors of bunnies become more dominant. So we still have a lot of white bunnies for a long time, but you can see we're starting to multiply the number of brown bunnies. So you can follow that. You don't have to have students look at the graph. And you can also do things like change the environment. So now it is the brown bunnies that are standing out. So there's lots of different things you can do with simulations. I will show a math one because I saw there was a question about math. Let me show you one which is good for middle-aged children. Middle school, not middle-aged. Middle-aged would be too old. If you wanted to teach children about things like averages, means, and medians, the balls allow you to do that. They allow you to predict where that median might be and to find out actually where it is. They allow you to do things like sorting so that I can see how I got the median. And I will stop showing. There's lots of things to explore, and my goal is for you to explore some things on your own. So like I said, everything is available from our website, but keep in mind, it can be really overwhelming the first time you go and look at this webpage because there's so many things to play with. And what's neat is you can even give students the, like if you go to the simulation, all you have to do is copy that URL and put it straight into, you just give it to the students, or you can tell them to go Google generator PhET. Let me go ahead and do that and show you what that looks like. If I were to just Google PhET generator, it's generally the first thing that will show up, and it will be right there. So you can tell students to do that. You can also download the simulation, and over here it's just an HTML file, and it will even work if you don't have internet. I see there's a question, do we have simulations for agricultural science? I will be honest, we really don't. We have some simulations that might be relevant. Things like we have one on greenhouse effect, but it's not specifically about agricultural science, but you know, it could be related. We have a lot which is about fundamental sciences. So basic physics principles, basic chemistry principles, basic biology principles, not as much applied science like agricultural science. And then I also wanted to show one more thing before I take a few questions. And that is, if you want to have all of the simulations downloaded, and if you have a Windows computer, for example, or a Mac computer, you can click on this button and all of it will go to your computer. All of the things I've shown you are free. There's only one thing that does have a charge if you want it, and that is a mobile app. The mobile app is generally around $1 US for the download, and we do charge for that to help maintain support for the work that we do. But honestly, you can just download even simulations to your own phone individually. You can even send the file, that file that I showed you up here, you can even put it in a WhatsApp or a chat, and students can open it on their phone. As long as they've downloaded the message, they actually don't even need to have any internet. And they can, a lot of people did that during COVID. So I'm seeing some questions. Can you create your own simulation? All of our code is open access. And if you go to source code, you can get it. But so yes, it is possible to create your own simulation, but not easily. Our simulations take about 9 months to create, and they end up costing us around 150,000 US dollars. Because it's not just about a coder creating the code. We also do a lot of research with students. We work with education researchers to understand what's difficult for students to learn. And we do lots of testing and making all of this accessible to learners. So it is possible, but we don't we can't create things on demand. And generally it takes like 4 or 5 people to make a simulation that's really, really quality. Let's see here. Are all the topics in science covered in PhET simulations? So no, because simulations are so intense to create, we do not cover all of the topics. That's something you'd need to look at. We do really, really well with electricity and magnetism and things like waves. We do really well with things that are abstract and hard for students to learn. So we don't, for example, have very many simulations about motion because there's so many great activities you can do with a stopwatch or even with a phone to look at how objects move. We don't have a lot of simulations about, I'm trying to think about what else we don't have a lot about, like things like agriculture and applied sciences. We just don't have very much. We don't have anything for anatomy as well. Let's see here. Do we have simulations for primary? Yes, we do. So when you go to this page, you can click by grade level. And I'm sorry, I showed you because I was a high school teacher. I was showing you more high school things, but we even have things for very young children. This is another math one. So things like learning about numbers. And one of the big ideas is one-to-one correspondence, that this number 1 here refers to this doggy over here, you know, or that one of the ones here refers to another doggy over there. But we can also do things like add, and suddenly those two numbers become one number. We can also realize that we could be talking about any kind of object, not necessarily just dogs. And then we can do things like organize our numbers so that it's easier for us to see how many of a certain object there are. So all of these kinds of things are very, very helpful for building fundamental concepts. And then for more like elementary learners, we have a lot in terms of understanding fractions and also equalities. So this here looks like it's a simulation all about, oh, a 1 over 1 is equal to 2 over 2. What about if we did 1/2 versus 2 over 4? And we can play around with seeing how, you know, basically equivalencies. Let's see here. What other questions do we have? Most, let's see. I mentioned that simulations can be downloaded. Yes, they can be downloaded on Android, but the mobile app does cost for a download if you want to do that. It downloads the whole package. Okay. All right. Well, thank you for everybody who's adding lots of comments and questions. I'm excited that Olalade has been using them for a while. There are simulations about radioactivity, all different kinds of things. So I would suggest you explore the website yourself, and then there are a few additional resources that you can get if you create a teacher account. So let me show you how to create that. If you go to the webpage in the upper right-hand corner, there is a little person symbol. You can register to create an account, and it's free also. It will ask you some things like your email address and if you want to get a newsletter from us. And once you sign in, so I'm going to sign in as myself, it gives you access to see a whole bunch of new resources with the app. So, sorry, not with the app, resources for the simulation. So somebody had mentioned radioactivity. This is called Build a Nucleus. And one of the resources that we have for every simulation is called Teacher Tips, and it explains how to use the simulation as well as what kinds of things you can do with students, what kinds of questions you can ask, and all that. In addition to that, we also have an activities tab where teachers from around the world contribute activities. So I'll just click on one so you can see what it looks like. And this one's actually a PowerPoint that goes along with the simulation and has questions for students to discuss so that you can show the simulation on the board, but actually like really, really have a meaningful conversation around it. Okay, I know there's gonna be lots of questions coming in and I'm sure that there's limited time. I'm gonna go ahead and take Baba Jide's question. Do you wanna ask your question?
Yes, good evening, ma.
Hello.
Yeah, I'm Babajide calling you from Jos. Yes, I want to ask, is this PhET simulation the same thing as virtual reality? Because like I'm a physics teacher and I've been using virtual reality to teach physics concepts. Like we can use it to teach theoretical and practical concepts. So I just want to know, is this part the same thing as virtual reality?
Great question. So no, this is not virtual reality. Virtual reality generally, I would say, involves three-dimensional, like immersive visualizations. But I will also say we've done a lot of research on what students need in order to learn certain things. And PhET simulations look a bit like cartoons, right? They don't look real. And sometimes people think, oh, you know, it's some people think, oh, it's not as advanced as virtual reality or augmented reality or something like that. But actually, we've found that students in certain circumstances, when we're trying to teach certain things, they get distracted by additional excessive information. So our designs are a lot simpler than some simulations out there because we have research that it actually helps the students to better understand certain concepts. So there's times when virtual reality absolutely makes sense. If you need an immersive experience, that's totally appropriate, but this is not VR, and there's a reason why it's not VR. So I hope that helps.
Yes, thank you very much. I'm grateful.
Yeah, you're welcome. There's a good question here because I know Blessing mentioned Lab Exchange. So I will share with you, I'm not going to go through the website, but I will put the link in the chat. Lab Exchange is a platform that hosts open education resources on its website, and that includes PhET simulations. I encourage you to use it. It has just lots and lots of other things. It has readings, it has other interactives. They do have more applied biology, like pre-medical or medical kind of science stuff and pharmaceutical stuff that we don't do. And it's much more, it's not VR, but it's a little bit more immersive. It's not as sandboxy as PhET simulations though. So it's more like following procedures as opposed to like inquiry, but that has its place too. So a lot of people are asking a lot of questions about how do I use this, or is there a simulation for this or for that? I'm not going to answer your questions because that's what the course is going to do. So Blessing, I think I've covered everything I want to cover. Can I hand it over to you now? You're muted, Blessing.
1 minute.
Okay, we hear
Oh,
you
yes,
now.
Rebecca. Oh, yes, Rebecca. Thank you so much. Okay, so
Great.
Rebecca has taken us through the PhET website, where to find resources, how to, get those resources, and how to open your teacher's account. Don't worry, on the group, I've done like short videos. I'm going to also share those for you to also watch in case you didn't come in on time. I see some people struggling because of the network. I'm still going to share that on the WhatsApp group. So it's always good you are on the WhatsApp group. I would share all those short videos I've used to explain how to create your teacher account, how to assess, your simulation, how to get further materials to help you kickstart using that simulation. Because I think, Rebecca, did you share where they'll get information about the simulation. Did you? I think you didn't.
I shared the teacher tips, yes.
Okay, the teacher tips. I should did that also. But
and it's also going to be in the course. So if there's anything people don't remember, just take the course. And everything I shared is in the first course, the introduction. Yeah.
Okay. So everything she's shared is in the introduction. That's what you'll be learning. You're going to be doing first. All right. So please, can you okay. Oh, Rita. Okay, good. So starting with Rita now would share with us the benefits of using PhET simulation. Okay, Rita, over to you.
Yeah, can you see my slide?
Yes, I can, Rita.
Okay, good. Yeah. Thank you. Thank you, Rebecca, for sharing. Yeah, I think I should put on my video. I'm sorry, I just want to find out what I was sharing. I'm not sure. Yeah, okay, it went off again. I'm going to go back and share again. Sorry.
Yeah, thank you, Rebecca. Can I see maybe claps for Rebecca as she leaves us? She has another meeting to jump into. Thank you so much for taking our time.
Yes, thank you.
Thank you so much.
All right. Things can go well.
Thank you. Yes, so here we go.
Thank you so much.
Yes. Yeah, so I'm going to be talking about the benefits, and I'm glad. Oh, yes, sorry. A lot of people are still, a few people are still talking. Yeah, so I'm glad Rebecca has touched on quite a lot of things so far. But it's still necessary for us to see why there's hype about using PhET interactive simulations, especially from the perspective of it as a learning technology and all the possibilities that it affords for us as teachers and for the learner, how the teacher is also able to, how it makes the teacher's work easy, and how it also aids optimally the learning process in your classroom. First and foremost, it is very interactive. I heard somebody asking if PhET is similar to virtual reality. PhET is not the same as virtual reality because virtual reality is immersive, but PhET, I feel, is better, like Rebecca said, because you are actually interacting with the phenomenon. You are not immersed in the phenomenon. And because when you're immersed in the phenomenon, the whole essence of the lesson might be lost. So you will see why, that happens, especially at a secondary level. Virtual reality becomes very useful when you get to the university levels, tertiary learning levels, where you now need to begin to maybe dip your hand inside the belly, augmented reality, dip your hand inside the belly of a cow to feel the different parts. That becomes necessary because maybe in Nigeria, we lack some of such laboratory practicals. We don't have enough cadaver. We don't have enough physical things. So that becomes very important. But at the secondary level, interactive visualization is very good, and that's what PhET simulation does. It fosters a very dynamic, moving, multi-representational image. So it's as if the phenomenon actually comes alive when children are learning with it. That's how PhET interactive simulation actually is.
Hello, Rita. Can you put your slide on slideshow?
Oh, Jesus.
Possible? Yeah.
Yes, please.
Okay. Then I don't know why your camera isn't. Anyway, just go on. Just go on. We
You
can
can't see it.
No. Yes, I think you might need to change your background.
Yeah, change your background.
Are you serious? You can't see
It's just dark. We can't see you. It's just dark.
Oh boy, that is not nice. Let me stop share. What's going on? And I've been talking. I thought it was my slide I was sharing. That's incredible.
I think
what was that all about? Hold on. Let me see this sharing thing that is going on. Yeah, Safari. Good. Can you see the screen now?
No, we
Hold
were
on.
seeing this. But
We were
your
seeing
own
the screen, but
We
we're not
can't see
seeing
the
you.
screen and we can't see you.
Okay, but just hold on. It's just
You are
saying.
seeing the screen.
Yes, we were seeing the screen.
The screen is loading.
Oh.
The screen is loading.
Okay, so now you're no longer seeing the screen.
But she's audible. Let her continue. We are hearing what she's saying.
There's no screen.
Okay.
Rita, don't
Please
bother
hold
about
on.
your
Let me
picture.
just go
Just
back.
share. Just share the way you share.
Funny thing is, my whatever has even disappeared. That's the funny thing. For some reason, my screen seems to have disappeared. I wonder why. Okay, sorry. Please just allow me one moment. Home screen is temporarily unavailable. Reload. That's terrible.
I think you can hear the audio.
So can you see now?
We can see
Can
you
you
on the
see
screen.
now?
No,
You
no.
can see me on the screen. Oh my God, what a day. Okay, let's go back to okay, so let me reload.
Let her continue
One
now.
moment,
We are hearing
please.
her.
We can only see your face, but you can't see your screen.
Yeah, it's okay. I'm trying to get there now. Okay, well, I'll try. Okay, I'll go on slideshow. Okay, okay, well, when I go on slideshow, it starts coming up. So now, hold on here. To get back on Zoom and now share from Zoom's. What is going on with Safari? Wow.
I think you need to log out and log in back, man.
Yeah, that is funny.
Rita, do you want me to share the slides? You want me to share for you?
Yeah, you know, I have actually done a totally different thing.
Okay.
And I'm sharing an entire screen. Let me see. Advanced. Okay. What's happening?
Or maybe you can send the slides to Blessed.
Okay. That's the funny thing. It's quite heavy. But let me try and get back. Okay, good. I think I can share now. Can you see it now?
Yes, it's up.
Yes, it's up.
Good.
Yes, it's fine now.
Yeah.
Thank you. You're so cooperative. Thank you. This is such a beautiful audience. Yes.
Yeah.
So good. I was talking about interactive visualization. It's just I've taken some of our time, but just be patient with me. I'll try and run through this. Now, when it comes to cognition, I always like to talk about this. It's very important. When we teach traditionally, our students learn by rote. Our students do not have anything to anchor the imagination. What PhET simulation does is that it gives the children, your students, the visual, the ability to see the process actually happening. So when you are teaching them concepts, or when they are actually engaged in concepts, scientific concepts in this case now, because we're talking STEM. When they're actually engaged in concepts and then they leave and you give them questions, their imagination, the visual they have seen is in their imagination. So they are able to easily recall and they're able to see the process they have seen. It's like having practicals. That's why we do practicals. But because in Nigeria and so many African countries, we do not have the fortune, the privilege of a good, equipped laboratories. That is why we especially are very passionate about PhET, because PhET is like bringing real phenomenon to life. It brings real phenomenon to life that makes it easy not to overload your students' cognition, so they don't learn by rote. Instead, they understand, because what you see, you don't easily forget. What you experience, you don't easily forget. So that is what happens. That's why these visual simulations are so much better. And then students are also able to self-assess. I will show you examples as we go ahead. And then it also helps them to, it reinforces learning. Multiple representations in different theories, in different dimensions, allows them, especially when they engage with it frequently, allows the learning even to be reinforced, for them, for assimilation to be easy. And then agency, it allows them to self-guide, to learn by themselves. One of the principles of very good learning is agency. Students are able to own their learning. That is where we start talking about student-centered learning. A student is now able, you as the teacher, you are now there to facilitate learning. Once the students grasp what is going on, they own the learning, and then you are just able to guide, to point out a few things and get them to focus on the process that is going on. You are no longer actively involved in teaching. You are no longer the sage that knows everything, but the students are constructing knowledge for themselves using the simulation. I'm going to just show you a simple, very simple thing that can help concept. Somebody asked about mathematics. This is elementary mathematics. I'm going to take you to the, sorry, I have a lot of sims here, so just bear with me. Yeah, so please open up. I'm going to quickly take you to the, yes, open link, take you to the link. I don't want to touch, you're going to bear with me. I don't want to touch this thing so that it doesn't move from here. But look at a very simple game, even for your kindergarten students. There are 3 levels. For PhET, it always starts from the smallest level and builds to the intermediate level, and it guides your student to the highest level. So you see, that's where the self-learning and the scaffolding process starts. So this is multiplication. For your children, even your children that are 3 years old, they can play with this. They can just say, what is 6 times 3? 6 times 3 is here. The student is able to understand that by the time they count these blocks in 3 rows and then count it down 6 spaces, it gives them the answer 6 times 3, and that is 18. You choose the answer and then you check. Can you see? It self-guides. Do you see that? As a teacher, so you can build with such. Even kindergarten teacher, you can use this to teach your kindergarten students, you know, how to do multiplication. And it goes on to factor. You are able to choose what factors, what times what will make 9. And then the students will now, from the experience they have had, they are able to say 3 times 3 can make 9 after going through. So there are stages. You understand it now. So let's go. I'm showing you, I hope you're seeing the screen. I'm showing you difference, and it comes to division. I'm not going to go too far into this, but basically you get the idea. So I'm going to go back to my place. Good. Oh, I'm navigating well now. Thank you. So yes, now after doing this, this is what I was telling you about. The PhET sim design is such that it is open, it is flexible, it is intuitive. When students press something, it's like a call and response thing. When students press a variable, when they manipulate a variable, they get the outcome of that manipulation. That is all that you see. That was what we saw when I was trying to sorry?
Continue.
Okay, yeah. So apart from that, in one of the very big thing that that you would get from PhET is the issue of promoting active learning. There is nothing like students learning actively, constructing learning. When I mean constructing learning, actively doing things. I'm sure a lot of teachers that I believe a lot of Montessori teachers are here. They would agree with me that children learn through play. PhET simulation is provides for students or learners from elementary phase all the way to even tertiary phase. But mostly I'm going to be focusing on the elementary and the secondary phase. That's why I keep saying children versus students. So please bear with me. Now, students and everyone learns a lot through play. So you can imagine when a student, like I showed you that game, that math thing is actually a game. Imagine giving your child that and he plays with it over and over again. Math principles, fundamentals begin to stick even though it is play. It is the same way we are talking about. That is active learning, even though it is through play. The PhET simulation supports such active learning. It engages the learners to use their hands to get into the sim activity, and it's more so as it is a fun, environment. These days, people say there's a myth that says that children of these days are digital natives. But of course, we all know that everyone can learn technology, even those of us that are not born in this age. I have a master's degree in digital technology. I wasn't born yesterday. So that's why I say it's a myth. Even you, we are bringing all this to you so that you can get on the train and use it to teach. Because like Blessing was talking about, the world has moved on. The things that we thought were the future is already in today. So our students need to get on the train and begin to learn the way learning is done globally. Now, I've talked about it being visual and interactive, and it is also safe and cost-effective. It also presents to the students real-world situations. This is of a very good advantage in our climb. I repeat, in our climb, because we all know the limitations of our society. We all know that science would have died off if not for things like practical online laboratories of different form that has been coming up, that has been popping up. Our practical learning of science would have died off if not for this. So using simulations allows you to learn things that are impossible to carry out, to arrange in the physical actuality of it. I'm going to give you an instance. Look at this. Look at this. This is a cannonball shot out of a cannon. If you are going to teach projectile, this is for physics students. This topic is usually called projectile in physics. If you are going to teach this class, there's hardly any, you can't have the opportunity to actively carry your students from the classroom to take them to a military cantonment to see an actual projectile being shot out so that they can do the experiments. You do not have the lab facility to conduct this experiment in your classroom for your students to see how a cannonball is shot out. And for instance, there are usually questions. My professor is going to go into more detail. But for instance, you want to ask your students, set this, please, you want to ask your students to tell you what would be the distance that a projectile will travel at a certain height. How would you, how would you expect the student to know, if not just by applying formula? But when the student is able to set the cannon at the height, that he wants to test it at, and then also be able to set it at a certain angle and see the different way the projectile will move, the student will be better able to answer whatever questions comes from that from the projectile lessons you're giving. Another vivid way is evidence of increased learning, like I was talking. This is a circuit. Watch what happens with this circuit. Watch when the light comes on, see how the current flows. When this wire is connected, see how the current flows, and then see the difference of how it shines when there are two wires connected serially and when there's just one wire connected. See the difference. So students are able to actually see physical electron flow Now, the experiment where this happened, in this, sorry?
Say good evening, great.
Continue, please.
In this experiment, the lecturer was trying to test, his students. So they were given practical practicals to conduct, and some were asked to use the simulation. After using the simulation to conduct the practicals, some were taught traditionally. They were taught theory, the way we teach in a classroom. And another group, the control group, the experimental group, were taught with simulation. The group that was taught with simulation, who actually saw the movement of this electron, look at the scores on the side. Look at the exam question. You can see that they scored higher on everything than those who were taught theoretically and then told to perform the practicals. The students that were taught using this simulation were better able to perform the practicals. You understand? So that is one of the benefits of this visual simulation. And then being able to manipulate it too is also very, very, beneficial for students. Another thing that the simulation does, that we have evidence of its ability to increase student engagement. One of the best ways to use the simulation when you come into the classroom as a teacher is let your students get a feel of it. Let them begin to play with it. Studies show that when students begin to play with a simulation, once you come into the classroom, the first 5 to 10 minutes, before you even introduce the topic, give them the link to the simulation. Or if you are in a place where you do not have, if internet is a problem, download the simulation on your laptop. If you have a projector, which a prof is going to talk about later, different ways you can do the teaching, show them the simulation. Just let it play and let them see. You will see that already, without you talking too much, your students would already be engaged in the subject that you're teaching. They will begin to pick interest. So it makes your work easier. Another way, and one thing that it brings me to the subject of your design as a teacher. Sometimes you might want to teach, you want to focus on content. Sometimes you want to focus on process. Sometimes you want to focus on your students attaining soft skills. You want to focus on higher level skills. If you look at these days, we are no longer looking at lower level skills of memorizing lists. You don't, as a teacher, you won't expect your students to learn how to list the 5 factors that affect motion. We have, by now, we should have stepped away from such lower level way of teaching, and then step into allow your students to develop higher level thinking skills. And these things, the sim is designed to help your students develop these skills. In your content, in the next sim, you will see how in this slide, you will see how the physics now, introductory physics, is arranged step by step. If you follow the syllabus, WAEC syllabus, most syllabus in physics always starts with measurement. From measurement, it goes on to motion. 1-dimensional motion, 2-dimensional motion, 3-dimensional motion. You can see motion of all dimensions. And then you start, it goes on to all the laws that affect motion, work, energy, and power moment. It goes step by step. So in terms of content, when you use the sim, you actually follow the contents in order. It helps you to arrange your work. So lesson planning becomes very easy, my friend. Lesson planning becomes very easy. I have been a teacher and I know how difficult it is to get quality material to teach students. I taught physics and I know how difficult it was. So with the PhET simulations, your lesson planning becomes easy. And that is one of the things you're going to learn as we go along in this course. This session is going to be 3 weeks before you go on Coursera to perfect what you have learned. And then, so if you need models, if you need example to model the things the phenomena you're talking about, you will find them in the simulations. If you want to bring out relationships, especially with math equations, you want to show relationships, you will be able to do that with simulation, using content from the simulation, from the sims. And if you also want to you want to explore process, if you want to see if your students understand process, procedure, method of doing something, you would also be able to do that in the simulation. The prof will break down how you can do all this. Now, if your target as a teacher is for your students to develop soft skills, to develop their argumentation and work collaboratively, if you want them to develop interactive skills, which is one of the principal skills that sharpens a student's intellect, the ability to argue and think through the process he is going through, think through his learning, present his opinion, investigate for himself what he is learning, so that learning stays, so that assimilation is easy, transfer is easy. The simulation would also help you to develop soft skills. And then for hard skills, laboratory technology, you can also learn this using the simulation. And what's more, it is enjoyable. Students love it. Students love learning with the simulation. So I have shown you the different subjects you have step by step, how it takes you through the physics theory step by step. And so you don't have to struggle, you just follow it as it goes. Then another way, active learning. I'm just giving you tips on how you can use it and different styles you can employ. For some countries, for some African countries, they promote the IBL, active learning, using the 5 E's, where you are talking of getting your students to engaging your learners, getting them to explore learning, and then getting them to be able to explain through presentations to their classroom, to promote their ability, their argumentative, their soft skills, and then getting students to elaborate on what they have learned, developing their own hypothesis, evaluate on it, evaluate their results, and draw conclusions and discuss them. You are able to do all that with the simulation. So I'm going to give you an example now. I have this here. I have this example lab activity. So this is just something that I have, I have written just to show you as a teacher sometimes how it would come across in the classroom.
Yeah.
So let's go to the
you.
sim. I think I have the sim.
You want to go to the sim, Rita? Time? Okay, we can't go to the sim. Yeah, because of time, Rita. Yeah, okay. I want let me just quickly. Okay, good.
Actually.
Okay. All right, we can't go to the sim, but basically, see, this is just you can use this to teach your students Hooke's law. You can use it to help them to understand stretch and how the spring constant influences, the ability, how measuring instrument. Now this is like a spring balance. You can use this to teach your students measurement and how measurement instrument accuracy affects the results you get. Let me just give you a small example. Let's say we connect. Can you see? I have connected 50 gram, and there's a spring strength here, and I've connected the same 50 grams. Sorry, let me lead it up. I connect the same 50 grams here. You see that one. Let's turn on the extensions. You see that one is more extended than the other.
Well, I'm not seeing
you can't see it.
Rita, it's
So
just
we can see.
We can see.
We can see.
Continue, please.
Go ahead, ma'am.
Continue. Go
You
ahead.
can see it. You can see it,
ma'am. We
please.
can see it.
Okay.
Thank you.
So you can see for yourself. We can make this thing bounce. If I put a heavy load, so that the difference is, so that you see what I'm trying to show you. Can you see the extension? Now remove the same spring. See the extension. Can you see that one spring is more extended than the other? So you would ask your students, what is the cause of this? You can help your students to understand possible causes of measurement differences. You can also help them. You can use this to calculate displacement. Put your cursor there. You can get in the other slide. You can actually calculate things like velocity. You hear? You can actually calculate things like velocity. You can help them to calculate displacement when they take measurements of these distances. You understand? So I'm not going to go too far, but I'm just showing you possibilities. Look at how I measured this. In this sim, look at how I measured this. I was trying to compare the extension of both of these two springs. So I used the ruler to measure the difference. So that difference shows you when you calculate the two differences using the formula you can see here, you're able to get the displacement, you know, and then your students are able to see and understand why, you know, you talk about spring constants, how it actually affects springs. So these are very, very simple little things that you should take note of. Now, having said all that, this is what would happen in your classroom as you do sim lessons. Using the sims allows you to move from just letting your students memorize Newton's law to actually exploring Newton's law and mathematical ideas. Students actually explore it. That little game I showed you before I went into all the other physics and math. The little child is actually exploring multiplication. And when he explores multiplication, he is able to understand factors that you multiply together to get certain results. Your class moves from just practicing standards, just quoting laws, just definitions, to your students actually exploring learning, inventing strategies. You can imagine your students will play with different angles of the projectile to see the different possible motion that is available, to see all the different distances that the projectile can travel. You can even change the laws of gravity. You can ask a question. So how do you think a projectile will behave in the moon? Your students can test how a projectile will behave in the moon. I have done this with my students in the classroom. It helps students to, you know, these visuals help students to retain knowledge. You know, so yeah, I'm going to stop here and we'll see again in the breakout room. So Prof, I'll hand this over to you.
Thank you so much, Rita.
If you have any questions, you could just ask along the way.
You can drop in the chat box because of time, and Rita would respond to you. Okay, Rita, you can also drop the links to the simulations you played with here and also on the WhatsApp group. Okay, so Prof, are you there?
Yes, I'm here.
Okay, over to you, my professor.
Thank you very much for having me. I'm actually running out of battery. I'm still back in the office, so I hope I will be able to deliver within the next few minutes.
Yes, please.
Warm greetings to everyone, and let me thank you, Blessing, for putting this together. I can see we have quite a number of people in the house.
Yes.
I'm really, really happy to be part of this development, and I believe we are learning how we can actually transform it in this part of the world. So please let me share my screen very quickly.
Yes, please do share. And please, I want to see, round of applause for Mrs. Rita for a wonderful presentation. In fact, she showed several simulations. Please, I want to see it in the group.
You would have done that since.
I'm so sorry about that because of
you
time.
would have done that since. After all, you are just concentrating. We see you alive.
I'm just focusing on the time because we still have a lot
I know.
So I am so sorry, Rita. In fact,
thumb up. Actually, it was a
you blew the
marvelous presentation. She did well.
Nice.
She did.
Please, I want to see it, please. Even with the hitches and all that, she still made, delivered superbly.
Yeah, sure.
So please let us see. Yeah, she's gonna share.
You can see me clapping, Ko.
Yeah. So
thank you so much.
I see people giving Gosa. Yes, if it's Gosa, please give the Gosa.
For STEM teachers, Gosa, we are doing a good job. It hasn't been easy teaching traditionally, but thank God for technology.
Yes. All right. So thank you so much, everyone. So my prof, over to you. Doing the finisher. I think that's for you. Thank you. All right.
Thank you once again, Rita, for your presentation. It was quite heartwarming. Let me welcome every one of us once again. I've chosen to pick this title, Promoting Active Learning with PhET Pedagogies in 21st elementary learners. I don't know if my screen is visible.
It is, sir.
It's not. Can you please put it on slideshow? Can hardly see it.
You can, if you are having problems, you can actually zoom in.
Maybe it's
on your
device.
slideshow.
It is on slideshow.
It is, Prof. It is.
Okay.
It is. It's showing. It's showing.
There you go. That's
Better.
perfect, right?
Yes.
Thank you.
Okay, you're welcome. Okay, now my name is Olayinka Akinola, and today let's first of all ask ourselves a simple question: why are you a teacher? I'm always happy to ask this question because many a times a number of us find it difficult to understand why we are teachers. And for some, is it money that you really want that makes you to be a teacher? I definitely believe it's far beyond money, because teachers are not even well paid world over. That is just the truth. And I believe the motivation for teachers should center around the following. You are there to impact lives. For me as a person, I've been in the teaching cycle for close to 2 decades, and I've had course of meeting my students, seeing them doing very well. And whenever I see that, it gives me a lot of inspiration that money cannot actually give. And so I see us as agents who are nurturing growth. We are fostering love for learners. We are the one who is empowering the world. Blessing and Rebecca, as well as Rita, they are emphasizing STEM. If you actually look at it, STEM is actually the driving force for the whole world. And so we are also creating positive change, and we are sharing our expertise. So as teachers, we may not have so much money. We may not have as much as politicians do. Definitely, we are impact makers, and we are actually touching our world. Now, in this presentation, I'm intended to achieve the following learning outcomes. First, is to describe the purpose and functionality of PhET, of which I believe some of these things have been taken care of by previous presenters. And then I'll also look at how we can apply PhET pedagogies to design engaging lessons. Take note of the word engaging lessons. It's not just about going to class and teaching your students. Does your teaching at the end of your exercise with the students, at the end of your encounter with the students, does it leave an impacting experience? Can you hear me? Yes, I should be on.
Yes, sir, we can hear you.
Okay, thank you.
Yes, sir.
Okay, thank you. So, my experience is not just going to class and just observing your period, just observing your time with the student. You should be able to leave the student with new experience on every engagement you have with them. And then
is there any problem? The house is quiet.
Simulations to promote critical thinking.
We are attentive, we can hear.
Please, Rita and Rebecca, you might need to mute people who are probably interrupting, please. Then we should be able to assess the impact of PhET activities on learning outcomes. And lastly, you should be able to adapt PhET activity to meet diverse learning needs. Adapt PhET activities to meet diverse learning needs. As teachers, your roles cannot actually be replaced with technology. Your roles are very, very critical, and you cannot be replaced. That is just the truth. Even though we were saying we are in the world of artificial intelligence, where so many things can be done, definitely the artificial intelligence will still require human intelligence to be able to drive it. That is just the truth. And so you need to be empowered with the right skills to be able to do the needful. If you look at the picture you have on the screen, I believe some of us are familiar with this kind of domain. Maybe 50 to 70 or 80% of us might still be operating in this kind of an environment whereby you struggle with so much tools to be able to interact and then impart knowledge to your students. Vis-a-vis something like this. This is a PhET simulation that is called a pendulum lab, okay? So in this kind of a simulation, you have the opportunity of even exploring different planets, how you can measure the period of oscillation in such an environment. Rita mentioned something like that. Is that okay? So you have this opportunity by making use of a sim like this. And I believe you saw this image earlier, whereby the interaction with the students can be more engaging and it can be more impactful with the use of what? Technology enhanced learning tools. And so I believe we will all be convinced, as some of us answered earlier, that if you need to actually engage the students, especially the 21st century student that I will mention very briefly, you need to be technologically inclined. And so look at what we have on the screen here. You can see from, let me quickly activate my pointer if it will be visible. Okay. Okay, this is my pointer. Look at this baby here.
Those guys are commenting and interrupting the class, please.
So if you look at this baby smiling, how old would this child be? Maybe 1 or 2. And you can see the level of immersion in technology. See this other one. Okay? So these children are referred by Prensky in 2001 as digital native. They were born into technology. And so if you, as a teacher, you need to engage a 21st century student or learners, you also have to be technology-enhanced teachers, not just traditional teachers. And so PhET has come to be a way of you engaging the 21st century student or learners, okay? According to Prensky as well, and then Hada, they refer to people who are older, maybe born before 80s. I don't know, maybe any of us, some of us might belong to that category. It refers to them as digital immigrants. That is, you are coming from the world where technology was not the order of the day. And suddenly you have found yourself, you are now a teacher, and every day you have to interact with students, learners who are digital natives. How do you engage them effectively? How do you engage them actively? How do you engage them to be able to actually impart them? Then PhET comes in as one of the key tools that you have to use. So how do we engage them? PhET is the way to go. We've talked about this. What is PhET? Of course. We'll still give it back to Carl Wieman, the man who won the Nobel laureate in 2002 and all the money. He won the Nobel laureate in 2001 and all the money he used it to start the foundation that is known as PhET today. Okay. Now, I will not want to dwell on this. Now, let me quickly talk about how PhET simulations are designed. What are the principles behind their design? It's very important so that you'll be able to know how to explore and how to use it. Now, the whole idea behind it is to help students engage in science and mathematics through inquiry. Now, inquiry is you ask questions and then you find answers to the question you are asking. Okay? Why is electricity flowing from the switch in my room to the bulb and the light comes on as soon as I press the switch? Okay? A PhET sim will show you how electron flows through the wire, and such will give you an impactful experience that you can hardly forget as a learner. Okay? PhET simulations are developed using the following principle in this particular order. Number 1 is to encourage scientific inquiry. I've mentioned that earlier. It provides interactivity, okay? Gives a lot of opportunity for interactions. It makes the invisible to become visible. What ordinarily you cannot see or what ordinarily you cannot achieve is what you can see. For instance, the electricity you have in your house. All we do is to plug your phone and then you charge it. What is happening within the cable or within the wire is not known, okay? But with the simulation like the one showed by Rita, we can see the electron flowing through the wire and how the light comes up, okay? Then use real-world connection, using of real-world connections, okay? That is part of the design principle. Multiple representation of objects, motion, and graph. Now, objects can be represented in so many ways using PhET sim, as you can see and as you probably maybe see shortly in my presentation, is to also show visual mental models. Then give users implicit guidance, and lastly, it gives the flexibility to simulation usage. So you have a lot of flexibility. There is no one cap fit it all when it comes to the use of PhET simulation. You can actually adapt it to your own learning objectives, to your own learning outline, to your own learning intended goals. Okay. Now, myself as a person, what was my experience, or how did I come about PhET? Very quickly. Sometimes in the early 2010, 11, 12, I found myself at a crossroad. I needed to conduct practical for physics students, undergraduate students, okay? And then we didn't have adequate equipment to work with. And so suddenly I stumbled on PhET simulation, and I was able to use it to effectively engage my students. I'm talking of university students, okay? And as a result of that, in 2016, the university gave me the Best Lecturer Award as a result of my engagement with the students. That award was not just unpicked, it was based on student assessment of their lecturer, okay? So it was the student that considered this man has been able to impact us by using this tool. So I give it to PhET Sim, and I believe majority of us will also going to use this tool to actually enhance our professional competency, and at the same time to also impart our students and our learners better. Okay, now what is active learning? Especially when we're talking about digital natives. I believe you all know what or who digital natives are now. Digital natives are referring to the students you teach on a daily basis, or the children that as soon as they're born in the hospital, the mother is placing a phone beside them. And as the child is even opening the eyes, the child is willing to struggle the phone from the mother. They were born into the technology. Okay, so active learning is actually an instructional approach that involves students in the learning process through various activities. So when we talk about active learning, it's different from a passive way of learning. It's different from having a sage on stage that is the one dictating the whole activity. No, the students are active participants in the learning process, and they play significant role in how their learning is done. So active learning moves away from the traditional passive learning, okay? And what are the components we can see there? It involves discussion. It involves several other methods. It involves problem solving, use of case studies, and hands-on experience. These are the components of what makes an active learning. It's not just a one-way thing, teacher just dishing out the whole thing. No, it's a two-way thing. As you play your role, then the student also respond, okay? Now, though the field is still evolving, so many things are still ongoing, at least according to Lombard 2021. It's a field that is still evolving, still growing. So many things are still coming up there, okay? Now, increase in student performance and then a satisfaction with learning environments was also reported in 2021 by a researcher, okay? What does that mean? That is, by the time you deploy active learning to engage your students, the students are more satisfied, their performance improved. And so it is the way to go if you actually want to improve the performance of our students. If you want learner satisfaction, if you want learners involvement, definitely is the way to go. So active learning is focused on the action students take to achieve the desired learning objective. The image you have on the screen is actually an image of a session I was having with an undergraduate student in my current university, where students, some of them come with their laptop, while some of them are also using their mobile phone to actually engage with the particular PhET sim that was being used at that point in time, okay? Active learning approaches demand a higher degree of responsibility on the learner, and the instructor's guidance is still crucial in the active learning classroom. I said earlier, your role as a teacher cannot be overemphasized. Forget about AI has come to stay. Of course, nobody is disputing that. AI is the way to go, fine, no problem. However, your role as a teacher is still very crucial as far as the delivery of educational content is concerned. But the question is, if you will still be relevant in delivering educational content, it's a function of, can you actually engage this 21st century learner effectively? I'm already having issue with battery low. Let me quickly rush through this. Okay, now we have the spectrum of the active learning. On one side, we have more of teacher control, and the other side, we have more of student control. These are the pedagogies that are deployed as far as PhET is concerned. We have the interactive lecture demonstration, we have the whole class inquiry, and we have concept questions with peer instruction. Let me skip this. Okay, characteristics of active learning. I'll quickly rush through this. We need to understand and then address student prior knowledge. Should be able to connect the content of a lesson to daily experience of students and apply it in different contexts. It supports collaboration. You can collaborate with your student to actually get things done. Create a safe environment for your students. That is what active learning provides. It also provides appropriate scaffolding, whereby you can actually begin to build the knowledge of the student based on their peculiarity, identifying their need, and then following through, okay? Then you can make assessment as part of learning process. Many a times, a lot of people in this part of the world make assessment as a punitive process or as a punitive way of dealing with the students. No, it's actually part of the learning process. And then to also establish certain practices and expectations as a response to specific behavior. So I quickly go to the pedagogy. Now, I have the whole class strategies. These are the strategies or the pedagogy. There are 3 of them. We have the whole class inquiry, we have the interactive lecture demonstration, we have the concept question. I will take my time to actually just show you briefly. Now, when we talk about the whole class inquiry, you have a settings whereby you need to interact with your student in class. Whole class inquiry leverage on the exploratory nature of the simulation in the context of a whole class discussion. So in this case, now you use a projector, you have a sim of choice, you have your objective, and so the student can see what is on the screen and they can actually interact with you. Then introduce a topic and help the student to broadly understand the natural or mathematical concept or system, okay? During the whole class inquiry, the teacher is responsible for guiding the conversation between the student and the whole class, okay? So this one is more of teacher-centered, okay? And these are the steps. I'll quickly run through this. I may not have the time to do for the others, okay? If you want to develop a whole class inquiry, you need to choose a PhET sim, okay? And Rebecca has done that, how you can choose a sim relevant to your learning objective. Then you brainstorm on the learning goals, okay, that you want to achieve with that sim. For each of the goals, then you come up with a series of questions that you go ask your students to generate discussion during the class, okay? And then be sure to include different type of questions, not just one type of questions. Then you order the question in a chronological order so that there could be a flow of learning from one stage to the other, okay? Now, interactive lecture demonstration, on the other hand, ILD, is a strategy that is especially useful in larger classes or when teacher wants more structure. In an ILD, teacher prepare a guided document. So in the case of interactive lecture demonstration, ILD, you have a working document. Blessing was talking about, at a point in time, you will need to develop an activity sheet, okay? So your activity sheet will include a way of having an ILD built into your engagement with your students, okay? Then this approach differs from the whole class inquiry by more systematically having students practice writing as they defend predictions or hypotheses, sketch diagram and represent mental models and compare various scenarios among other skills, okay? So in this case now, the students are also involved in writing because we are giving them a sheet whereby they will respond to questions and then they will answer questions, they will sketch, they will do 1 or 2 things. Then these are the process also to be able to design that. You choose a scene, establish the learning goal, and then plan at least 3 demonstrations, whereby you will give the students step-by-step guide on what they should do. Then you order your question, and then you give the activity sheet to the student to work with, okay? Then we have the concept question, lastly. It's another active learning strategy that leverage on dynamism and multi-representational nature of the simulations. It focuses around specific questions and potential answers supported by discussions among peers. Now, teachers can use this strategy to focus student thinking.
Please, we should be mindful of prayer time. Thank you.
Okay. Oh, wow. I think his battery, he said is, Edo State University is quite far from the township. So electricity problems, we all know what happens in university. At least most of us, we went to university here. So we all know what happens on campus. Okay. So
no, university now have solar. So universities have solars now with technology. They have solar
Okay,
systems installed.
all right.
We are
So
not
there is
Maybe
no
it's your
excuse.
own
If
university.
Prof is busy, he did not charge his phone. We understand. But universities have lights.
We hear you. We understand. We are
No,
not
it's
bad.
a rainy season in Nigeria presently.
Okay. Okay, let me not make any excuses or too much excuses for my bro. I mean, I will always make excuses for him. Maybe he was busy and he couldn't charge when there was
That one I can agree. And you know he's a device man, so he has been using device all over. I did not remember to charge it.
Yes. But
Okay,
please let us
I'm
be
happy.
mindful of prayer time, please.
Okay, yes,
okay, I think
please. I know.
In the next 10 minutes, most of us will be going for prayer. I can see some have started leaving the meeting already.
Yes.
I'll suggest the
Okay,
prof
hold on first, Mr. Timothy. Please let us mute our microphones, everyone. Please mute your microphone. Okay. So because of prayer time and we just have 10 minutes left. It's so much because I wanted us to do go into breakout sessions where we have subject expertise in those rooms and we go through some particular simulations. But I think we shall do that next week, Wednesday. We shall mark our time. I think that will be the first thing we do next week, Wednesday. Go into those groups and, play around simulations. We're going to do that next week, Wednesday. Okay, so because of time, please, if you have any questions, I want your hands raised. We're going to pick just 5 questions because of time, 2 minutes. Quickly, I want to see your hands raised. It's only those that raise their hands.
Faith Mawa, you can unmute and speak.
Yes. Faith, you're the first person, please. Unmute and speak. Faith.
I also have something to say, ma'am. Good evening, everyone.
Okay, can you raise your hands, then we'll call you. Is that okay? Okay, please, I want, if you should see the hands raised icon.
Please, can you begin to speak?
Faith, are you here? If you're not, okay, Mr. Mohammed, please speak.
All right. Good evening,
sir.
all.
Yes, sir.
Can you all hear me?
Yes,
we can hear you, sir.
All right. I first of all want to thank you for giving us this opportunity to attend this session with you. I've looked at the PhET simulations, all the sims there. And most importantly, the ones you exemplified were easy for me to carry. But the other ones I want to try on my own, I didn't find it actually user-friendly. At some point, I don't even know what to do, despite the fact that she said there are teacher tips. I don't know, is there any easy way, any tutorial I can get from the site? Or, tutorial, I mean, so that it will be easier for me to really work with it. Thank you.
Hello.
Okay. Let me answer that question quickly.
Hello, Blessing.
Okay. Yes, you're back.
Sir.
Yes, sorry, I'm able to make it back, but I may not have video again, please.
No,
okay, we have to pause because of time. So we've already gone to just questions and answers. Can you stay with us on that?
Okay, that's fine. That's fine.
Yeah, okay. Okay, so let me quickly
if not responded to my question, ma'am.
Yes, I'm coming to you, sir.
All right.
I'm coming to you, sir.
This is not a new section. She might not be able to answer to your question. She might not be able to answer to your question. This is a new session.
Please, can we, this is Q&A right now. Please, can we just follow through? Okay. So when you get, Mr. Muhammad Ali, when you get to any simulation, okay, you can see my screen, right?
Blessing.
Yes, I can.
One of the things that you're going to start doing, you're going to be given the videos. Once you get on the Coursera course, the videos that you're asking for, those are what you are going to be going through. It will lead you to know how to learn how to use the sim, and then how to use them to produce activities for your students, design activities for your students. So it's actually what you're going to be doing on the course as you go along.
Okay. Okay. So
just to
add to what Rita is saying. All right. So you come to teaching resources, you're going to see things there. which you see the teacher tips. You have to be signed in. You have to open an account. As I said, on the Coursera introduction, you're going to find all those things there, how to do it. You're going to see here activities. Activities are things that people have done in the past with this simulation. When you click on it, you will see the materials. You can now read through those materials to learn more about the simulation. Okay, so that's it. So the next question is from Blessing.
Good evening, everyone. Thank you, ma'am. She has just replied me. She said I should open an account with the Coursera, and then I will get the answers I'm looking for. I also want to ask for the video because my network was very bad, and then I joined at about I think 5:50, so I couldn't get the initial aspects of the meeting. Thank you.
Okay, no problem. Thank you. Mr. Amos, you can speak.
Yeah, good evening, ma'am.
Go, it's almost time for prayer. Sorry, please. We have to subject us, leave us. I don't know how we're going to do this, really. I don't miss a single thing on this thing, and I have to unfortunately go because of time.
Oh, do you have a question?
Yes,
no, I'm very okay. I'm very okay. My question, I think we've not even got to mathematics. So, like, I'm very okay what I'm saying. Physics, quite all right. I'm impressed. Thank you very much for the opportunity. And I wish all of you luck. Thank you.
All right. Thank you so much. And I hope you will be around. You're going to join the course on Coursera and work with it till the end.
Sure, I will.
Okay. So I hope you're on the WhatsApp group so you have enough support.
I've been seeing you saying welcome. No problem. Don't worry. Yourself.
Okay. All right. So any questions?
I'm also a device man, just like Prof.
Okay. Okay. Good. Okay. So any questions? You can, any support for my Muslim brothers and sisters as you leave, any support, please make sure, let me quickly share the WhatsApp link quickly again. Make sure you're on the WhatsApp group to any support you need. I will be there, okay, to reply you and help you out.
Thank you very much. So come on, please give me my umbrella. It's raining over.
Thank you so much. All right, so Mr. Amos can speak, please.
All right, good evening, ma'am.
Yeah.
Yeah, sorry to come in with a question like this at this time. I actually joined late. Like it's not been long I joined, just few minutes back. So someone sent it to a particular group I'm in. So I followed it up, I registered, and then here I am, but I'm kind of like confused, like what are we doing? Like what are we doing here? I don't know if I can
if you're on the WhatsApp group, that's fine. By the end of
no,
if you're not on
WhatsApp, I'm not on the WhatsApp group. I'm saying that I saw a link inside a WhatsApp group I'm actually into. So I followed it up and then here I am. That's what I'm saying, man.
Okay, yes, I know, but we can't go back totally. So what
I think Blessing, let's quickly give the link for the person to register now so that he can also receive.
He has registered. If he's here,
he hasn't. The link was shared on a different platform. He hasn't registered. So he only saw the link to join the meeting and he joined.
Okay, please, I've shared the WhatsApp link now. Can you please join that link? I'm sharing again. Join the group. And from there, you'll be carried along. You can ask your question and we'll share.
I will also paste the link to register for the conference for you to receive all the necessary correspondence.
I've joined.
You've joined, okay. So I'm pasting the link for you to register for this particular event.
Okay.
All right, sir.
Okay. All right. Thank you, Amos. Mr. Olasunmade, please, can you speak? You can unmute. Shakirula. Okay, if you're Mr. Chinaza. Please, you can unmute your microphone and speak. If you can hear me, you can unmute. You're allowed to unmute. Mr. Elida Chinaza, can you speak? You raised your hands. Okay. All right.
Hello, ma'am.
Okay, hello, I can hear you.
Yes, I actually want to ask a question concerning how people that are just joining the class for today's session, how easy would they catch up with the former classes that have been done, and how can they get the materials as well? And also for today's classes, my network was fluctuating, so I couldn't grasp the whole thing entirely.
Okay, no problem. So you're going to continue on Coursera, all right? Please make sure you're on the WhatsApp group, all right? And we'll be dropping all resources
I've just joined the WhatsApp group.
Okay, good. So after this call now, you would I will share other informations on how to start. Okay? So please read through the document. I'm going to send a document that each and everyone should please read before you start. And the video recording of this session is going to be shared, all right, on the group. I think within like 2-3 hours later at night, when the internet is quite sound, I would upload it and you can watch the video recording. Okay, so you have not missed much. Today is the first class.
Exactly.
Okay.
This is the
So
please
this is the first class.
slide presentation.
All resources will be shared. Please just be on the WhatsApp group. Okay. Chinaza, because of time, I think we're going to take your question.
Okay. Hello. My question is, how can we implement this in early years education? This PhET simulation of a teen, how can an early years educator implement
were you here? All right. Were you here when Rita presented? Huh? If you were not here when Rita presented, there are early year simulations, all right, to help them with their maths. All right, so that is where those are the sims that you work as an early year class, early year teacher. When you're going through the Coursera course, for the PhET Coursera course, you will see it will direct you on how to pick simulations. So you go look for early year simulations and pick that and work with that. Okay?
Okay. Thank you very much.
Okay, so final question, Emmanuel, final question for tonight. Sorry, we're 7 p.m. We don't want to keep you. Final question for tonight, Mr. Emmanuel Ogodo. Are you with us? Are you with us, Mr. Emmanuel? Your question has been answered. Okay, thank you. Thank you so much. Thank you so much. All right, we have come to the end of today's webinar. I think I'm just going to leave my co-facilitators. Sorry, Joy, we could not go into the breakout session, but next week, Wednesday, we are going to go into the breakout section. Okay, last few words from you. Professor, last few words. Prof, Olainka, any last few words from you to encourage everyone to keep on with the course and finish through?
Thank you, Blessing. I want to appreciate everyone, first of all, for being part of this event. And also, I want to encourage you, please, ensure you follow through this process. It's an opportunity for you to be a world-class professional. And then it pays to actually add value to yourself. It's a rare opportunity because you don't really know when you will need a skill that is coming to you freely now. So thank you and enjoy the rest of your evening.
Okay. Rita, last few words of encouragement to all participants to pull through to the end.
I think Prof has already said it all. Nobody knows when they would need these skills. The way the world is going, teacher application will soon be, what technology skills do you know? Do you know how to use technology to teach in your classroom? Not just asking if you know how to use a computer, but do you actually know how to use educational technology packages to teach? So you see, the world is stepping up. The future is now. There's no longer, it's no longer business as usual. So I would encourage you, like Prof has already said, embrace it and open yourself to learning. Allow yourself to learn. There's nothing like digital native. Nobody was born from heaven and came down with a computer in their hand. You know, we're all We are all, everyone has the ability to learn and relearn. So I'd encourage you all to really finish this course, get certified, and be proud to show off your certificate. Put it on LinkedIn that you are a certified PhET expert. And I'll encourage you to come in on Wednesday next week. The person that is going to be taking the breakout room is somebody that has gone through this course before. So by the time you see her confidently teaching you how to use the PhET Sims, just by attending a course like this, you will see that, you know, there's a difference, and I'm sure you would want to emulate it. So I wish us all the best.
Okay. All right. So thank you so much. All I just want to do is encourage you. I'm working for you. I'm here for you. I'm on the WhatsApp group. Okay. Any questions you need, please, I want you to cooperate with me. I'm going to drop a document. I want you to read that document carefully. As I said, to start, yeah, this is Joy. Joy, in a few minutes, you know, no, let me even stop. Joy, please, a few words to encourage all other STEM educators to pull through. Please, a few words.
Evening. I am happy to be here. But I just want to say one thing. For whatever reason you are in the teaching profession, you need PhET simulation. For whatever reason. Is it for impact? Is it to make money? I urge you to finish this course. Do this course. You will come back and thank Mrs. Blessing for this opportunity. I have done this course and I will forever remain grateful. I thank her from time to time whenever I get something from what I have learned. For whatever reason you are into teaching profession, you need this course. I urge you to finish it. Thank you.
Thank you so much. She's an online teacher and she uses PhET to teach online. She teaches one-on-one tutoring and she uses it. So please, see, I'm not going to lie to you. Let me not scare you. But I tell you, this course, you need to really sit down, take your time, soak it in, think, create your activity sheets, and you'll be so proud at the end when you pull through and, you know, that reward of getting that certificate. Please, I urge you to do. So please cooperate with us by reading the documents now. I'm going to share on the group. As I said earlier on, Rebecca has sent 4 emails. You're going to receive 4 emails tagged Nigerian teachers. Okay, Nigerian STEM teachers.
Nigerian teachers. Okay.
Nigerian STEM, wait, let me go back to that. Nigerian STEM teachers, please, I want you, immediately you receive those 4 emails, please do join it from that email. As I said earlier on, you know, Coursera is a paid platform, but PhET has made this free for us. Coursera is a paid platform. You pay $69 per month, but this is free. If you don't join through the emails, the invites sent to you, okay, you will be charged. So please, I beg you, join through the invites sent to you. 4 invites. Immediately join those 4 courses. So there are 4 courses: intro, you have whole class inquiry, you have activity design, and you have implementation. Sometimes the emails might not come together. There might be spaces, like it might take time before others drop because of the server, you know, dropping the emails. So please search your box for this. Once you search PhET, it should bring up everything about PhET. All right. And please join the course through Coursera, through this, okay? And I'm going to be sharing a document very soon. So I apologize for taking our time to this time. So I encourage us to please pull through. I'm on the WhatsApp group to take all your inquiries. I will open the group soon, maybe at night, not now. Okay, yeah, I'm going to open the group now. All right. But before we all go, all right, before we leave this meeting, I want an exit ticket. And what is that exit ticket? I want you to let me know what you've learned today. What you've learned, everyone in the chat box. That is once you drop that, then you can leave. Once you drop your exit ticket, then you can leave. In the chat box, please. Once you drop, I'm just coming, Mr. Gabriel. Okay, maybe that's your exit ticket. You're just coming, don't worry. The video recording would be in the WhatsApp group. Okay, I'm going to share it, all right? And also, I will share it to your emails too. I see some people are saying the WhatsApp group is full. I will open another WhatsApp group and I will send emails to everyone. So please do check your emails to receive a mail from me
I've learned
with
to engage.
things. Okay,
Engaging
so
the 21st century
yes,
children.
enrolling is free. It is totally free. How to? Okay, good. All right, good. I see. What have you learned today? I learned how to use PhET simulation. Beautiful. Thank you. Whoa, thank you. You're welcome. I learned a lot. My curiosity is sorted. Okay, good. Goals. Oh, you learned what physics is. That's physics engineering tech, and that's PhET, physics engineering technology. Nice, nice. So please, yes, I see a lot people dropping it, what they've learned today, how to make learning effective, active learning for digital natives. Great. So thank you so much, everyone. And we apologize for taking 8 minutes further of your time. We apologize. Wednesday, please let us meet up. We're on the WhatsApp group. We're not too far away. We're just a chat away. Okay. So you can drop any thing you need us to support you with. We are on the WhatsApp group to support. So thank you so much. As I bring this meeting to an end. Thank you. And I think I have to just thank God for today, for keeping the network well. That's my thanks. All thanks and glory to God. Thank you, Jesus, for today. All right. So thank you, everyone, and see you in the WhatsApp group, and also see you next week, Wednesday. All right. Bye. You can unmute and wave. Rita, my prof, Joy, thank you so much.
Prof. Thank you, Mrs. Blessing. Thank you so much.
Everyone. Thank you, Blessing.
Thank you, facilitator. Bye.
That's a great job. Well done.
Thank you.
Bye.
Thank you, Professor. Thank you, Madam Blessing. Thank you, everyone that made the meeting very
Bye.
possible.
Bye.
Bye.
Thank you.
Thank you.
Bye, everyone.
Thank
Thank you,
you.
everyone. Thank you, the
Thank
host.
you, Madam Blessing.
Appreciate it. Thank you so
Thanks so
much.
much.
Thank you, everyone.
Thank
Bye.
you.
See you next
Love
Wednesday.
you.
Thank
Bye.
you.
Wednesday.
Thank you. Bye.
Wednesday, see you.
Bye.
Bye. Bye.
Bye.
Thank
Jamie.
you. Bye.
Bye, Adeluka. Bye, Grace.
Bye,
Bye.
Ceci.
Yeah, bye, Faith. Bye.
Bye.
I can see Mr.
Oluwatoba,
Blessing.
bye.
Bye. Isabel, I
James,
can
bye.
thank you. All the
Bye.
intention teachers, thank you.
Oh,
Bye,
bye.
bye. I
Bye.
really enjoy your teachings. Thank you.
Oh, you're
Bye.
welcome.
I enjoy
Welcome,
your
Mr.
teaching
Johnson.
too.
Oh, thank
Bye.
You
you.
guys are
Thank you.
wonderful. Bye.
Oh, thank
Next
you
week
so much.
Wednesday, I may be one of the first people to join.
Oh, nice. Thank you.
Bye.
Thank you
Bye.
for that encouragement. Thank you. Thank you,
Thank you,
James.
thank you,
Bye,
Thank you,
bye.
Faith.
ma'am. I can
Faith,
see
I see you
you.
there. Thank you.
Yes, sir.
You are really happy.
Bye,
I
ma'am.
see.
Been trying. Thank you, ma'am.
No problem. Olubumi, thank you.
Thank
Thank you so
you.
much. Thank you.
Thank
Thank
you.
Thank you very much.
you so
Sincerely
much.
appreciate you. See you next week. Bye.
Yeah, thank you. Thank you. Thank you, Adenuga. Thank you, Kalista. Thank you. Thank you so much.
Thank you, Auntie Blessing. We appreciate you. See you next week.
Yeah, thank you, Folake, Mrs. Folake. Thank you. Thank you, Moses. Thank you.
Yeah, welcome, ma'am.
Thank you.
Turn up to you.
Thank you so much.
Turn up to everybody.
Thank you, Felicia Babalola. Thank you. Thank you.
I didn't hear my name. I'm jealous. Come on, mention my name,
Mr.
please.
Johnson, Mr. Johnson, thank you.
Please don't be jealous.
Mr.
Now I'm
Johnson,
happy. Now I'm happy. Thank you so much.
okay, Mr. Johnson, thank you. All right. Thank you
My
so much, everyone. Thank you. All right, bye. Bye.